Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases.
Hello everyone, welcome to episode 8. We'll cover question number 36 to 40 in this episode. For questions 1 to 35, please refer to previous episodes of this series. Let's get started. Question number 36. A business relies on Amazon S3 for object storage. The organization stores data in hundreds of S3 buckets. Certain S3 buckets contain less frequently accessed data than others. According to a solution architect, lifecycle rules are either not followed consistently or are enforced, in part resulting data being held in high cost storage. Which option will reduce expenses without jeopardizing object availability? In this particular scenario, we have S3 object storage being used as a storage solution, and we have different types of data here. So some data is less frequently accessed, some data is more frequently accessed, and the access pattern is unpredictable. Now, normally, if you know the access patterns, then what you could do is you can move certain data that is not needed from S3 standard storage to infrequently accessed tier. And if you don't need something, you want to archive something, you can move it to deep archival. However, whenever you don't have understanding of how the data is going to be accessed, it becomes very difficult. And that's the problem here. We don't know the access pattern. Lifecycle rules are probably there, but they're not enforced properly because we do not have consistency in terms of how data needs to be accessed. So because of all of this, what's happening is we are paying a lot more for the storage than we should. Everything is sitting in S3 standard. You are paying irrespective of whether data is being accessed frequently or not accessed frequently, or even it might be never accessed. You are, for all the data, you are paying the cost as if you are accessing everything frequently. So that's the problem here. The cost is something that we need to solve by figuring out a solution. Now, what could be the solution? And this is not the first time AWS must have encountered this particular issue. This is a very common problem that the data that you have a lot of data and you have different categories of data. And we have a solution for that. Every time you see unpredictable access patterns in S3, you need to go for S3 intelligent tiering. S3 intelligent tiering monitors access patterns and automatically moves objects that have not been accessed to a lower cost access tier. So you can see this diagram. This is from AWS documentation. You have your S3 bucket here, and you have chosen the storage class of S3 intelligent tiering. Now, this internally, what it does is it keeps the most frequently accessed data in the bucket here, frequently accessed data in some other internal storage, and anything that is, say, not accessed very regularly, say, not accessed for consecutive 90 days, is going to some sort of archival storage. And the cost for each of the storage is different here. So overall, you pay much lower cost than having everything in S3 standard. So this is your solution. This will make sure that your problem goes away with respect to the cost being high for storing data in S3. Now let's see what options we have in the questions. So we have 4 options here, and we can see our option, which is S3 intelligent tiering storage. Let's see why we are ruling out other options. So the first one, use of S3 ACLs. This is an incorrect option, as we know. Basically, it controls who can access object, but this won't affect the storage cost. So you can create S3 ACLs and then decide who can access, which resources can access S3 objects. But that's just for access control. That's not for controlling or tiering the data and moving it from one storage to another. So cost will not be solved using this option. So this is incorrect. The second option is option B, which is also incorrect. It says use elastic block store automated snapshots. Again, this is an incorrect answer. EBS snapshots are for backing up block storage volumes, not for object storage. So absolutely wrong. So we rule that out. I'll skip option C. Let's look at option D here. It says use S3 one zone infrequent access. So what is being suggested here is go for another storage class, which is fair enough. But when you move stuff to S3 one zone infrequent access, so first infrequent access, so you're moving to minimize the cost, you're moving data to infrequent access. Now, ideally, you cannot move everything to infrequent access because you need a solution which has some data that needs to be frequently accessed and goes in the right storage tier for that. Some data might be infrequently accessed, goes in that tier. Even if we ignore that part, even then, one zone means data will be stored in one zone, which basically compromises on availability. So from both availability perspective as well as trying to get a solution for having uh, data in the right storage tier based on how frequently it is accessed, this is an incorrect solution. So we rule that out. The final answer is option C, S3 intelligent tiering storage, which is what we discussed at in detail in the previous couple of slides. So this is what we'll go for. Option C, use of S3 intelligent tiering storage for minimizing the cost for storing data in S3 where we are not aware of the access pattern. Here is some documentation from AWS around Amazon S3 intelligent tiering storage class. You could go through it in detail. Also, there's a short video here. Please go through it. I'll give you a bit more understanding of what S3 intelligent tiering storage class is. From an exam perspective, I think you just need to remember one aspect, that wherever you get a problem or a scenario where you have mix of data in S3 or any sort of storage, and you're not 100% sure of what will be the access pattern, uh, then you need to use tiering storage class. That will be your solution for cost effectively managing the storage. That's it on this question. Let's move to the next question. Question number 37. A business uses Amazon Elastic Container Service to perform an image processing workload on two private subnets. Each private subnet connects to the internet through a NAT instance. Amazon S3 bucket are used to store all photos. The business is worried about the expenses associated with the data transfer between Amazon ECS and S3. What action should a solution architect do to save money? What problem we have? Here we have an ECS service which is used to do image processing. Each private subnet connects to an internet through NAT instance, and Amazon S3 buckets are used to store all the photographs. So we need to figure out the data transfer between ECS and S3, where ECS is processing the images and S3 storage, how that expenses is optimized. And there are various options here. The first option says configure a NAT gateway to replace the NAT instance. Now, replacing a NAT instance with NAT gateway may provide some cost savings, but does not address the underlying issue of data transfer cost. What we are trying to solve is the data transfer between ECS and S3. We want to make it optimum from a cost perspective. So this is an incorrect option. Let's cross that out. Next wrong one for me is option C. So option C is wrong for me. It says configure an interface endpoint for traffic destined to Amazon S3. Interface endpoints only allow connecting the VPC to service powered by private link. S3 is not supported by interface endpoints. So this is not going to be the right application. So option C is wrong as well. Option D as well appears to be wrong. It says configure Amazon CloudFront for S3 bucket storing images. Now, CloudFront can help latency or with data transfer speed, etc., for external users of the S3 data. So if you have end users accessing S3, CloudFront can help, but it won't help with the internal transfer between two services, which is in this case ECS, which is the compute, and S3, which is the storage. So that's wrong as well. Option D can be ruled out. So that leaves us with option B, and option B is the correct option. Configure a gateway endpoint for traffic destined to Amazon S3. Gateway endpoint allow private subnet resources to connect to supported AWS services like S3 without needing an internet gateway, NAT device, VPN connection, or direct connect. So you don't need all of this. You can just use gateway endpoints to connect your AWS services like S3. Traffic between the VPCs and AWS service stays within the Amazon network, reducing the transfer cost. So in this case, what's going to happen is in this VPC, your traffic will remain within the Amazon network and you're not going onto internet. And thus it basically saves the cost of data transfer because you're using your own network and you're not using public network for data transfer. So you never leave AWS network infrastructure in this case. So that's your correct answer, option B. Use gateway endpoint for traffic destined to Amazon S3. And here is some piece of documentation from AWS around access through a gateway endpoint. I will provide a link for this particular article in the video description, which you can refer later. But I think here also a similar scenario is given. We have an S3 bucket. In AWS, we have VPCs and some resources in VPCs, and gateway endpoint is used to access the resources in S3 from your services in VPC. So that's it on this question. Let's move to the next question. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 38, an online picture program enables users to upload photographs and modify them. The application provides two distinct service levels, free and paid. Paid users' photos are processed ahead of those submitted by free users. Amazon S3 is used to store the photos while SQS is used to store the job information. How should a solution architect propose a configuration? So what scenario we have here is there is a service which basically processes the photographs from the users. Users can upload the photographs to this particular website or a online program. And there are two levels of subscription or service levels, free and paid. Paid user photos are processed ahead of the free users, and the data is stored in S3, and SQS is used for processing the jobs or storing the job information. So how a solution architect can design such a system where paid users are given more priority ahead of free users? There are various options given here. Let's go through each of them one by one. So option A, it says use one SQS FIFO queue, assign higher priority to the paid photos so they are processed first. Now this is not going to work. Assigning priority within a single queue does not guarantee absolute order. So this is going to risk paid photos being missed. So one FIFO queue is not going to work. So for that reason, option A is gone. And same is option D. If you see option D, it says use one SQS standard queue, set the visibility timeout of the paid photos to 0, configure Amazon EC2 instance to prioritize visibility settings so paid photos are processed first. This option is also not going to work. Option D is wrong. 0 visibility timeout leads to immediate redelivery of messages upon failure. So when you have 0 visibility timeout, the photos are not reached, immediately those would keep redelivering, and this overall this is going to increase the cost of processing, and it will cause race conditions as well. You need to allow some sort of latency and delays in the overall solution in order for it to work. So both the options, option A and D, they are trying to use one SQS FIFO queue, and it's not going to work. So those are gone. Now we're left with two options where we are left with two queues. Option B uses two queues. Option C uses two queues. But if you see, in case of option C, they are both standard queues. And then it is saying, let's use an Amazon EC2 instance to prioritize polling. Now that's not going to work. Standard queues do not guarantee order, and relying on EC2 for polling is unreliable. This solution is not going to work. Now that's why option C is wrong. And that leaves us with option B. Option B says, let's use two separate FIFO queues, one for paid, one for free. And this is the correct solution. Separate FIFO queues with optimized polling offer guaranteed order and service level differentiation for paid users while minimizing the cost and latency. So as part of the solution, we are saying, okay, let's set the free queue to use short polling and the paid queues to use long polling. And that's how you guarantee a different priority for different jobs. So this is the correct option. And that's the answer for this particular question. That's it on this question. Let's move on to the next question. Question number 39. Application developer have found that when business reporting users run big production reports to Amazon RDS instance that power the application becomes very sluggish. While the reporting queries are executing, the RDS instance CPU and memory usage metric do not surpass 60% of its capacity. Business reporting users must be able to produce errors without impairing the functionality of the application. Which action is necessary to achieve this? So what do we have in terms of problem description? We have a system where there is a database being accessed, and that's Amazon RDS. There are certain users who are also accessing this database for reporting, and database is getting overloaded due to multiple users. One is the transaction processing, which is on the top, and then the business users accessing the same database, and it's slowing down the database, but it is not surpassing its memory usage metric. So memory wise, it's all good. So how do we solve this problem? So we have a transactional load here and we have a reporting load, and both are accessing the same database. And because of that, I think the impact will be noticed on transactional load. The reporting load will slow down. It must be doing complicated queries, and it's probably slowing down the transactional load. Now, the best way to solve this is you need to separate the loads. So you have your transactional load here that can talk to your database as a primary database, and then you create a replica of that database, and that replica can be connected to the business users, and business users can run their complicated queries for generating the reports they want. Thus, you have the transactional load is not impacted by business users, and your problem of performance or slowdown or delays in getting transactional updates, that disappears. That's our solution. We have done this in past as well. Whenever your database is getting overloaded due to reporting systems and transactional systems accessing the same database, you need to basically separate the load and create a read replica, connect the read replica to the reporting system, and keep the main primary database connected to your transactional system. So that's what the answer would be. Let's see what options we have here. First one, we have, it says increase the size of RDS instance. Now, if you increase the size of RDS instance, that's not going to solve this problem. It is unnecessary. The instances CPU and memory usage are under 60%. So we are not seeing that the database is not coping up because of its size or the capacity. It's because you have multiple access points or into the database, and we need to separate that load. So this is incorrect. So increasing the size of RDS instance is not going to help. Let's see the second incorrect option. Now the second one is saying, option B says, let's create read replica and connect application to it. Now read replica is fine. We saw that that's our solution, but you shouldn't collect application to it. You should be connecting application to your main database, and you should be connecting reporting application to your replica. So this is incorrect for that reason. The next one, which is incorrect, is option C. Option C says, let's enable multiple availability zones on the RDS instance. Now, availability, when you deploy a particular solution in more than one availability zone, that is your reliability solution, not a solution from performance perspective. So it will help in disaster recovery, but it's not going to help in this scenario that we have here. So that's an incorrect option. Rule out option C as well, and that leaves us with option D, which is the solution we have discussed earlier. Option D is creating the read replica and connect it to business reports. So your overall solution will be, you'll separate the transactional load from the reporting load, and reporting load is connected to replica, which will keep performing any queries it needs without impacting the transactional load. So that's the correct answer. So option D is the correct answer for this particular question. That's it on this question. Let's move on to the next question. Question number 40. A business operates a website that is hosted on Amazon EC2 instance spread across 2 availability zones. The organization anticipates traffic increases around certain holidays and wants to provide a consistent customer experience. How can a solution architect satisfy this criteria? We have 4 options here. Let's go through each of these one by one, and we'll eliminate the wrong option to arrive to the correct answer. So first option, it says use step selling. So what problem we have here? We are saying, we have a solution that is using Amazon EC2 instances, and they are across 2 availability zones, and we are expecting traffic increase during certain holidays. Now, when we are saying certain holidays, that means, say, let's say Christmas or a Black Friday event. So when is it going to happen? When are you going to get a higher demand in your traffic? So you know the time. Now, if you are able to put some scheduling which is around that particular period, then you could be able to solve this problem. And that's how you can, choose the answer. Now, if you look at A, B, C, D, the D is the option which says schedule scaling, which is around, let's figure out the time period when we are going to get the higher traffic. We are expecting the higher traffic, and let's schedule auto scaling to increase or adjust the load or number of EC2 instances based on that. So that's the answer, option D. But let's eliminate others and see why they are incorrect. We have a few options here. Let's eliminate the wrong ones, and we'll see why the option we just discussed is the correct one. So option A and B, option A says let's use step scaling, and option B says let's use simple scaling. Now, both of these options are not going to scale up quickly enough for a known upcoming change. So in both these cases, the change is going to be stepwise. In some cases, it will be manual as well. Both simple scaling and step scaling reacts after changes in metrics. So they may not scale quickly. Basically, is put scaling based on the metrics on how much load you have, and it will wait for metrics to change. Within all of these, in this whole process, you might see an accumulation of a lot of traffic and slowing down the system, maybe taking it completely down. So both option A and B is not a good option for a known load on a particular time period. Yeah, this is not going to work. So option A and B both is not going to work for a scenario where you are anticipating a much higher load. So that's why we'll rule out both option A and B. They are incorrect. Now, third option C, use lifecycle hooks. Lifecycle hooks allow you to perform custom actions during launches and terminations, but don't directly help with scaling capacity. So that's incorrect for that reason. So that leaves us with our option that we've discussed. This is a known load on a particular time period around certain holidays. So we'll use schedule scaling. So it will allow you to set auto scaling to increase or decrease capacity at specific times. And this will allow the architect to plan ahead and ensure sufficient capacity around holidays when traffic increases expected. So that's our answer, option D. And I believe that's the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you.
This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.